Hello there. Today we're going to be taking a look at how to find the greatest common factor of monomials, and we're going to use that to help us factor linear expressions. Now, the easiest way to explain how to factor a linear expression is basically to tell you to undo the distributive property. Now, some educators and some mathematicians will put the distributive property and factoring linear expressions into the same term of the distributive property. And that's why I explain it that way, because we learned that multiplying numbers into a parenthesis help us distribute a number. When we factor, we're actually going to take that number right back out. So to give you kind of an idea, just a quick look at what I'm talking about, look at this example. If I told you that we wanted to distribute and we had 6 times the quantity of 2x plus 3, I'm sure that most of you would just say, oh, Mr. Blows, this is what you do. Multiply 6 times 2x. 6 times 2x is 12x. And then you would say you multiply the 6 times the 3. And 6 times 3 is 18. Now, when we want to factor, what we're going to do is we're going to start with 12x plus 18, and we're going to ask ourselves, what number can we take out of 12x and take out of 18 through division and still have whole numbers? And when we look at 12 and we look at 18, we realize that both can be divided by 6. So we would put our 6 out front, and 12x divided by 6 is 2x, and 18 divided by 6 is 3. And so our solution would look very similar to how we started the distributive property. That is what we're going to be looking at today. So to get us started, we want to take a look at some vocabulary terms. Monomial, which just means that we have a single term. Factor, which are the numbers that are used to multiply and make up a number. So let's take a look at this real quick. Factor. We used 12 just a little bit ago. And so the factors of 12 would be 1 and 12, 2 and 6, 3 and 4, because those are what we multiply. So we would say the factors of 12 are 1, 2, 3, 4, 6, and 12, because those numbers can be multiplied to make up 12. All right. When we talk about factored form, that is just that last form, which looks like we're about to start the distributive property. That's what factored form is going to be. So what is the greatest common factor? Well, this is kind of what we learned when we first learned how to simplify fractions. Simply put, the greatest common factor is the largest number that can be divided into both of the given numbers and leave a whole number of an answer. So I give you some steps. Step 1, list the factors of the two numbers. That just means all the numbers that are multiplied, just like we did for the 12. List all of the numbers that we can multiply to make that number. Step 2, circle the common factors. So once you have your list of both sets of factors, we want to circle the ones that were found in both lists. And to find the greatest common factor, obviously, just choose the one that's largest and found in both lists. So here's an example. I chose 72 and 81. I listed all of the factors of 72. 1, 2, 3, 4, 6, 9, 8, 12, 18, 24, 36, 72. A lot of factors. Then I listed the factors of 81. 1, 3, 9, 27, 81. And I circled the ones that are the same. 1 is found in both, 3 is found in both, and 9 was found in both. As a result, 9 is the largest of the common factors, so therefore it is the GCF, or the greatest common factor. Now, at the same time, we can do this with variables. Notice I used the same list. The only difference I said is we're going between 72x and 81x. So I put the x at the end. So what we would do is we'd still find the greatest common factor, but because x is found in both of them, we would add that on to our answer. So at the bottom here, you'll notice it's the same, except we just add the x at the end. So it's instead of just 9, it's 9x, because x is the variable found in both. So let's look at another example. Okay, this one's a little bit simpler than 72 and 81. It's 4x and 12x. So here's what I would represent. I would say the factors of 4x. Well, we know it's going to be x. We also know it's going to be 1 times 4 and 2 times 2. So I try to list them in order if I can. So x, 1 times 4, and 2 times 2. Now I'm going to list the factors of 12x. So I know it's x. I know it's 1 times 12, 2 times 6, and 3 times 4. Now notice I kind of made like a little rainbow effect here where I chose 1 times the largest number, 2 times the next largest number, and so on. That's a great way to try to make sure that you have all of the numbers needed. The next thing I want to do is I want to circle the numbers that are the same. So I have x's in both. I see 1s in both. I see 2s in both. I see 4s in both. And I run out of numbers, so there's nothing else that's higher. So the greatest common factor, remember, GCF means the greatest common factor. X, 1, 2, and 4 are common. The greatest common factor is going to be 4. So my GCF is equal to 4x. And I use the x because we see that's in both of those. We don't know what it's going to be, but it's going to be multiplied by whatever our greatest common factor is. So 4x is the GCF. Let's try another one. Now these are a little bit larger terms, all right? So I'm going to write this just a little bit differently, okay? So I'm going to write this as 48x, 28x, and I'm going to list these vertically. So I know that I have x in both. And then I'm going to list the factors next to each other. 1 times 48, 2 times 24. Can 3 go in? Sure. We have 3, and 3 goes into 4 one time, and then it's 18, so that's 16. Or 4 times 12, and 6 times 8. Now, if I look, these are in order. They go 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. So they kind of make a U now. So let's list all of the factors of 28. Well, we know it's 1 times 7, 2 times 14, and, oops, not 1 times 7. Sorry, 1 times, got ahead of myself here. 1 times 28, and then 4 times 7. There we go. So again, this is a little bit different method, but I'm going to circle the commons. So I know that I'm going to have an x. We know that we have 1. We know that we have 2. We know that we have 4. I don't see a 6. I don't see a 7, all right? And I don't see any other numbers. So therefore, 4 is the largest. So we would say that it's 4x as our GCF. Okay. Now, this is one where we have multiple variables. So again, I'm going to list this as 18a with my first variable being a, then 1 times 18, 2 times 9, 3 times 6. 20ab, I have a, b. 1 times 20, 2 times 10, 4 times 5. So of the variables, I have a. Of the numbers, we have 1 and 1, 2 and 2, and that's it. So because 2 is the largest number that is common, and a is the only variable, we would say that the GCF would be 2a. We would not include the b because 18a did not have a factor of b within it. Here's another similar example. 16s and 40st. So again, 16s, I'm going to list my factors. My variable is s. My number factors are 1 times 16, 2 times 8, and 4 times 4. Now, because it's 4 times 4, I really don't need to include the second one. It would just be the 1, 4. 40, on the other hand, has 40 times st. So I would have the s, the t, and then 1 times 40, 2 times 20, 4 times 10. I'm going to scroll down here a little bit, give myself some room. We have also 5 times 8. So let's go ahead and let's mark our commons. First of all, I know s is going to be a common variable. We have 1, 2, 4, and 8. 8's the largest number. S is the only variable. 8s is our GCF. So 12CD and 36CD. We have C, D, 1, 12, 2, 6, 3, 4. For 36 CD, we have C and D. 1 times 36, 2 times 18, 3 times 12, 4 times, 4 times 9, and 6 times 6. So again, variables C and C, D and D. Numbers are 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, 12 and 12, and that doesn't go any higher. So because 12 is one of the factors, because it's multiplied by 1, we can use it. It still can be an answer. And notice both of the variables were common. So our greatest common factor would be 12CD. Pretty straightforward. Now, I want to share one with you. Let's imagine that we had, let's go 13x, and let's do 15xy. So if I wanted to find the GCF between these terms, I would list my terms just like I've been. So 13x has the variable x, and then it has 1 and 13, but those are the only factors. And 15xy would use x, y, 1, 15, 3, and 5. So when I'm looking for the common ones, I would say that we have x on both and 1 on both, but that's it. So because of that, we would say that our common factor here would just be the x. All right, we can put the imaginary 1 in front of it and say 1x, that's okay, but we'd also know that 1 times x is just x. So that would be a common factor between 13x and 15xy, because there are no really, 1 is the only number, the variables are the only thing common. What would happen if we didn't have any commons? Well, we could just put 1, or we could just say that there are no other common factors. That takes us to this type of a problem. Now, what this is factoring our expression. So I want you to imagine if we have 3x plus 9, I want you to imagine it as two different numbers. So we have 3x and we have positive 9. So I want to be able to factor this out, okay? Now, this positive sign I'm going to ignore right now. And I'm going to say, what are the factors? What are the factors of 3x? Well, we know that it's x, and we know that it's 1 times 3. And what are the factors of 9? Well, there's no variables. It's 1 times 9, and then 3 times 3. So the factors that are common are just the 3. So here's what happens. We take the 3 and we place it outside of a parenthesis set. Now, what goes inside of the parenthesis, all right, is the other, what would be left. So what is 3x divided by 3? Well, it's just x. And what is 9 divided by 3? Well, it's just 9. And we put the plus sign in the middle. Made a mistake there, didn't I? Divided by 3 is 3. There we go. Don't want to make mistakes, but I leave it on the video. I don't want to edit that out because I'm proving, hey, we all make mistakes, right? As long as we catch them before we move on. So let's try a different problem here. Sorry, I keep making these stray marks. My notepad is very sensitive today. So we have our 12x plus 48, and we want to factor this. So I'm going to write the factors of 12x. So we have x, 1 and 12, 2 and 6, 3 and 4. For 48, we have 1 and 48, 2 and 24. We have 3 and 18. 3 and 16. We have 4 and 12. We also have 6 and 8. Okay. Now let's look for our commons. What are our common factors here? So we want to identify. We have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 6 and 6, and the one that you probably all saw right away was 12 and 12. Okay, so 12 is the greatest common factor. So we're going to take the 12 out. Now, we have to take what's left in the parentheses. So what's left is going to be 12x divided by 12 is 1x. 48 divided by 12 is 4. Now, you might also notice that we took out this 12, and the number that it was multiplied by originally is what stays in parentheses. Same here. We took out the 12, and the number and the variable, because we didn't use the variable, was what's left inside the parentheses. So just another kind of hint for you. If we're writing out our factors, we can use that to help us write our final expression. All right. So that takes us to this problem, which is somewhat unique. And what I want you to look at is we have 12x, and the factors of 12x are x, 1 and 12, 2 and 6, 3 and 4. And we have 7y, and the factors are y, 1 and 7. And you'll notice that there are no other commons other than just the ones. Now, we could put a 1 outside of parentheses, but they would stay the same because the 12 and the x would stay and the 7 and the y would stay. So we would just end up with something that looked like this, 1, 12x plus 7y, which really kind of makes that more complicated. So if 1 is the only thing that we can pull out, we would actually say that this cannot be factored. So there's nothing that we can take out of it. So we would say cannot be factored. Okay. 3x plus 11. Again, we have x, 1 and 3. No variable, 1 and 11. The only thing that's common are the ones, so cannot be factored. Cannot be factored. Okay. This equates it to the area of a garden. Now, the following says that we remember doing our area array. So what we're looking at here is kind of like going backwards through the area array. We want to know what number could we have put out in front of this actual area. So let's look at 15x and 18. So I'm going to list these. We have x, we have a 1 and a 15. We also have a 3 and a 5. For 18, we have 1 and 18. We have a 3 and a 6, and I don't want to forget about 2 and 9. But I know that I see 3 and 3. So really what we could say is, let's put the 3 out front of the area, right? Remember doing that? And then what's left would be the 5x up on top and the 6. And when we write this, it would actually look like that. So we could write this as 3 times 5x plus 6. So what we're doing is we're taking that area array, if you remember when we talked about the distributive property, and we're working backwards. Now we know what the answer is. We want to work backwards and find out what are the actual factors that we multiplied by to get our area. So I wanted to share that example with you. And again, what we're looking at here are just factors. The easiest way to do this is to write out all the factors. And that is why early on we had done so much work with knowing our multiplication facts, making sure that we understand the fact families and how they relate to each other. So I encourage you, please continue to watch this video or go back and watch the video again if you do not understand. I also encourage you to look into the book. And in the book, they do have not private tutors, but they have tutor videos that will explain these again. And you might hear it a different way, and that always helps. What we're going to do next is you're going to try your homework. You're going to have the rest of the class period to work. And if you have any questions, please make sure you write them down, and we will talk about them when we're back in class together